let's solve for the integral using one of the most important laws in mathematics, which is the laws of exponents. So here we are asked to find the integral of x plus 4 all over square root of x with disrespect to x. And currently, actually, I currently had a new stylus pen which could help me make better videos, better calculus videos, mathematics and physics videos. And yeah, I really like the stylus pen, and it actually helps me a lot when it comes to computations. Let's go ahead and proceed to solving this integral. Now this antiderivative of x plus 4 all over square root of x, it may looks complicated, but if you know the laws of exponents and how to split these into two terms, then we can solve this. Alright, so let's go ahead and split this into two things. So first, this is equals to the integral. Oops, let's just fix that. So the integral of x plus 4 multiplied by 1 all over square root of x. Oops, let's fix that real quick. Let's fix that real quick. Man, the stylus pen is actually really good. Okay, so well, it's probably because of a feature that they have. Anyways, so multiply this by 1 all over square roots of x. Now, as you can see, we have now split them into a product of two terms, which is we're multiplying x plus 4 to 1 all over square root of x. Now, let's apply our laws of exponents in this specific term, which is 1 all over square root of x. As we all know, according to the laws of exponents, 1 all over x is equals to x raised to the negative 1. However, according to our laws of exponents as well, square root of x is equals to x raised to the power of 1/2. Alright, so if that is the case, then let's apply both rules. So now we have the integral from x raised to the 1/2 all over negative 1. Why? Because it says here our 1 all over square root of x is equals to square root of x negative 1, raised to the power of negative 1. However, our laws of exponents also says this, so we need to apply that too. So therefore, we have x raised to the power of 1/2, and then we close that into a parenthesis, and then raised to the power of negative 1. Alright, so I can't fit it here because our platform is very, very small. So we're gonna go ahead and erase this entire thing, hoping that we don't forget a single detail. So now that we know that we can use the laws of exponents to solve this integral, then we can solve it. So we can go ahead and say this is x raised to the power of 1/2 negative 1 raised to the power of negative 1, and then times the quantity of x plus 4. Alright, next thing that we need to do, the next important thing that we need to do is that we can go ahead and do another laws of exponents application. So according here, this is similar to a law in exponents which states that x raised to the power of m and then also raised to the power of n is equals to x raised to the power of m times n. Alright, don't forget the dot here. That also means multiplication. Don't confuse it, guys. That also means multiplication. So in our case, m is 1/2. In our case, m here is our 1/2, and our n is -1. So therefore, x raised to the power of 1/2 and raised to the power of -1, that simply equals to x to the -1/2. Okay, so now we're moving on to the right direction, because now we can simplify further our integrand as the integral of x raised to the power of -1/2 multiplied by x plus 4. And we can go ahead and use the laws of exponents again in order to multiply this using the FOIL method. Alright, I mean, it's technically not a FOIL method because this thing is like only one term, but I'll just call it that way. Don't forget dx because the calculus people in the comments will kill me. Alright, okay. I'm just putting dx because the calculus people are gonna kill me because that's an important part of the integral. Yeah. So anyways, so we have -1/2 plus 1, because remember, another thing that we need to know is that in the laws of exponents, x to the m multiplied by x to the n is equals to x raised to the power of m plus n. And that's an important thing. That's an important thing to remember in order for us to solve the integral effectively. Okay, so now let's go ahead and solve our integral further. Let's further simplify this. So now we have the integral of, okay, so -1/2 plus 1. Surprisingly, this becomes positive 1/2. So we have x raised to the power of positive 1/2, and then x times x to the -1/2 multiplied by a constant, which is 4. So we have plus 4x raised to the power of -2. Alright, so in that case, so if that is the case, we can go ahead and solve our integral. Alright, so we can finally apply our power rule, the law in antiderivatives, or we call this the power rule. So according to the power rule, the integral of x raised to the n is equals to x raised to n plus 1 all over n plus 1. And I know, yes, my handwriting when it comes to n is very terrible. Thanks for pointing that out. Okay, so let's go ahead and apply it. So we simply have 2 all over 3 x raised to the power of 3 all over 2, because 1 plus 1/2 is equals to 3 over 2. And then we have plus 4 multiplied by x raised to the power of 1/2 all over 1/2. Now remember, guys, we have an invisible 1 here, and this is divided by 1/2. We can go ahead and simplify that. As we all know, 1 all over 1/2 is equals to 2. That's surprising, isn't it? Yes, it is. It is surprising. So let's go ahead and write that as 4 times 2x to the 1/2. So therefore, our final expression is 2 all over 3 x raised to the power of 3 all over 2 plus 8x raised to the power of 1/2. And don't forget the plus c. There we go. And that is our answer for today's integral. Pretty fun, right?